Hello, everyone. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Mehmet Abdullahi, the organizer and the community lead of this great community. So, it is one of those sessions that are in a different times, time slot on my end. It is 9 p.m. So let me just share my screen and let's see what we have for today. Cool. Day, October 3rd, 2025, 9 p.m. Pacific time. The session number 47, Fabric Coffee at Microsoft Fabric Cafe. And as you know, or you don't know, you should know that we are part of the Microsoft Learn community, the Microsoft Tech community. Uh, we are actually, which is a great place to learn and find out all things about Microsoft technologies and whatever that falls in front of Microsoft and Azure landscape. There are different user groups and learning groups that you can join them, especially for the Microsoft Fabric Cafe, which we are focusing on Microsoft Fabric and Power BI. We have weekly Fabric Coffee sessions with great speakers from around the globe, and we are almost 5,000 members globally and presence in different channels. So we provide learning and support to Fabric users in all levels, and it is a forum for everyone to learn, share, and grow the skills together. Uh, if you're new, uh, or you haven't joined any of these channels that we've got on different platforms, you can just follow us on YouTube with the handle of Microsoft Fabric Cafe. You can just follow us on LinkedIn, just on the YouTube channel. You can just watch all the past sessions or upcoming sessions, including this one, if you want to rewatch it or share with your network. On our LinkedIn channel, we do all our announcements from at the community, from Microsoft Fabric or Microsoft Learn, whether that is new or relevant, basically. And we have presence on Microsoft Community Group and Microsoft Fabric Community. You can also join us there. And most important one is the meetup group that you have, that we do our announcement for the sessions, and you can do your actually RSVP there, right? And more important than that is you can just rate the sessions and let us know how we can do the things better. And of course, you can do the networking. When you join the session, you can see the network, who has been in that session, and just make your connections and expand your network with the relevant people for sure. And there's a code of conduct when you join the live sessions. Uh, thank you very much for adhering all of these things. I'm not going to read them. The past week we had Steve Campbell. He introduced us to uh, version control, Git, and Power BI dev mode. If you missed that, you can just watch it on our YouTube channel. It is available there in the live section. And for today we have Praveen Kumar Bandi, uh, engineering intelligence at scale. So he's going to just talk about the distributed data foundations for the Microsoft Fabric era. And I'm super excited to learn from him. So let me just invite him to the stage and let's see what he's going to teach us today. Hey, Praveen.
Hi.
Welcome to Microsoft Fabric Cafe. I know it is very late for you. It's 11 p.m. So
Hi.
thank you very much for making your time in advance. And so we have only one message here. Let me, yeah, yeah, from Aishir. Hi everyone. Hello. Thank you for joining. So yeah, I'm not going to take the time from the live session and share your screen, Robin, and
Sure.
you can just go for it, guys. Ask your questions and let us know what is your feedback on the session, or let's make it more engagement. And good luck and enjoy it.
Thank you, man. Hi, everyone. Good morning, good evening, good afternoon, wherever you are. Um, I'm today we're gonna talk about the distributed data foundations for the Microsoft Fabric era. Right. This is the session today, and let me give a quick introduction about myself. Right. One sec. I think I'm facing some issues with the screen. All right. Yeah. I'm Praveen Bandi. I have about 2 decades of experience in the IT, mostly focusing on the data management, data architecture, data analytics, cloud and data-driven transformations across various industries, including financial services, retail, and healthcare. Right. So currently, I'm working at a large financial services organization, leading an enterprise data architecture practice there. Um, so today's session, on a high level, we're going to cover how the data is exploring in today's world, the challenges with the data growth, which everybody is seeing today, and how the decentralized data systems are keeping up with the exploration of the data, right? And what is the distributed data foundations are, and how the distributed data engineering could help solve this problem in the world of Microsoft Fabric, or the lake houses on the open architectures coming. Everybody is embarking on as AI meets our real-time intelligence, right? How these all come together and how the distributed data foundation could help meet the needs of the AI and whatnot, how the future would look like, and we can talk about some question and answers from there. So, so today mainly the engineering at a scale, right? So enterprises are reimagining their data architectures in the world of the data analytics, the data lake houses, or the Microsoft Fabric with where more agility, scale, and intelligence are no longer an optional, right? I think so. Everybody is going towards these modern architectures and modern technologies, right? And where the distributed data is a foundational capability to achieve the scale and agility which is required to meet the current business needs. So this session, we are going to explore how organizations are moving towards the distributed data architectures, and how can they overcome the struggles or the challenges, the centralized data architectures, which have been there for a few years now. And also we'll dive into some of the challenges, opportunities, and also the architecture shifts which are reshaping the modern ecosystem. So as we all know, right? I mean, the data is the key for everything which is happening in the today's world, right? Like every activity and everything which happens today in the enterprises is all shared by the data. So as industry expects, right? The data would gonna explore about 150 plus zettabytes by end of 2015, which is which is the kind of exceeding the limits of our central architecture which today's organizations are following up with. So mainly the conventional centralized models can no longer keep up with the phase the data is going today, so which is leading to slower performance, and also escalating or increasing a lot of infrastructure costs to maintain the data, and also growing the risk of system bottlenecks, right? So again, as this backup, distributed data engineering has emerged as a vital strategy to meet the demands of the data exploration. So, also the AI and ML is also coming together, which requires a low latency and high volume data specific to a domain where we're going to use those models towards it. So all come together. The traditional data architectures are failing to keep up with the exponential growth of the data to meet the current business needs. So right. So as we take that into considerations, right? I mean, why the existing the conventional data architectures are uh, fall short, right? So mainly the centralized architectures were designed for a time when the data growth was slow, right, and which was predictable. But today's in reality, it's very different. The horizontal scaling breaks down, the latency piles up, the cost spiral just to keep the lights on, right? I mean, just adding the compliance and the governance to it, which pressures more and then tracks the widen up even further. So now we all know that everybody is understand that message is clear that it's time for the new foundation, one built on the distributed ownership and true state scalability. So this is where like organizations are rethinking their data architecture landscape to see how could they could move uh, their architecture towards the distributed engineering and the data architecture to keep up with the growing needs of the business needs, as well as the growing exponential growth of the data. So, what is distributed data engineering, right? I mean, distributed data engineering is mainly marks a foundational shift in the enterprise data strategy, right? Instead of forcing all the business units of the domain within the organizations, right? Uh, Forcing everything into the one central repository or one central data platform. The distributed data engineering distributes the compute and the storage across the domains, unlocking the parallelism, resiliency and efficiency. So this approach is mainly boost the agility, which improves the single point of failure and helps organizations to adapt a real-time, dynamic workloads. So I think this is all leading towards, the domain-driven data ownership on the data products, right? So it's mainly the organizations are thinking towards decentralization of their data pipelines and the storage, which is closer to their source systems, leveraging some of the open formats such as the Delta, Iceberg, right? Which kind of allows the interoperability and also gives the flexibility of the compute and the engines they could choose to process the data, and at the same time gives the central governing the security and the governance at the center, where the data can stay within the domain specific or closer to the source of its own, which kind of giving us more flexibility, right? And the data can be processed near to the source. However, it's all governed centrally through enterprise catalog or whatever, like the ownership could go organization level. So which kind of gives mainly some of the key benefits, right? It kind of gives the elastic scalability, the fault tolerance and resiliency, the democratized one access and the ownership. So mainly the scalability can across the compute and the storage. It can interoperability with multiple engines, like so for our legacy data warehousing systems fall right, and which has to go through the same compute or the same vendor product to process the data and use it for the consumption standpoint. This kinds of opens up and gives flexibility for the organizations to choose engines or fit for purpose engines to process the data to meet their needs, and also at the same time giving a metadata driven governance at the center, leveraging the catalogs. Also gives ability for zero copy data sharing, support for the real time and the batch workloads to meet the growing business needs. So this is the power of the distributed data engineering, which would help organizations to think and then move towards in this new world of lake houses or the data Microsoft Fabric, which actually fits very well into this architecture. So this slide is simply showing, right, how the conventional centralized the data architecture would look like, where all the business units of the domain specific data is being pumped into one central repository, and from there everybody is used to consume it, which kind of causes a lot of bottleneck, right? I mean, it has to go through a centralized pipelines to process ingest the data into the repository, which kind of cause a lot of delays in processing it, single point of failures, and at the same time causing a lot of latency issues for the consumption as well. Whereas the distributed data engineering, where the data and the compute would stay within the domain specific area, and it can be processed there, and it interconnected with the multiple domains, and it's all governed from the central catalog. So which allows the parallelism, resilient, and no single point failures as well. So as we all know, right? I mean, the lot of modern data frameworks which came into the rise, right, with open source communities and whatnot. So the rise of these frameworks, such as Apache Spark, Flink and the Microsoft Fabric's native engines has completely reset the expectations of the performance, right? Enterprises that adopt these tools are already seeing, up to 10% faster analytics, as much as 50% lower in infrastructure costs. So, and these aren't just the lab experiments. I mean, we have been seeing these go into production and seeing the results in the real as well, right? Proving that distributed data engineering is both the powerful and also economically viable. Since we don't have to stick to one vendor product or one vendor technology to process all the data centrally. Instead, we could keep the data which is closer to the domain or a source, right? And kind of process it there. And whereas all of this interconnected via a metadata or a centralized catalog, and kind of establish a centralized governance as well, where all interconnected. So if anybody wants to consume this data, they could leverage the catalog to know where the data is there, and consume from there instead of pulling all together into one centralized platform. It gives us more flexibility, agility, as well as saving the cost in terms of the processing costs in specific data domain at this each domain level. So this is all maybe going towards the data mesh, right? So I think as we have been seeing in the industry, all the Fortune 500 companies are adopting the data mesh technologies, right? I mean, we're seeing 40% of them are already in the data mesh, moving towards domain-driven ownership, right, and treating the data as a product. So which aligns with the central governance standards. So the power of the data mesh comes from the domain-oriented ownership, right, where business units manage their data as a product while still adhering with centralized governance standards. So I think when we take about the Microsoft Fabric's OneLake, right, which actually amplifies this model, improving the discoverability, consistency, and the compliance across the distributed domains. So the data fabric comes with it's OneLake and to manage the data, and then the pure view for centrally managing the governance and the security at the center. So this is just a kind of a pictorial representation of how the data mesh plus OneLake would come into the life, right? So I think we would have OneLake at the center, which kind of allows the discoverability, consistent, and the compliance of the data, whereas all the domains across organizations are interconnected through a catalog, where the processing, the stories of the data are specific to a specific domain itself instead of centrally coming together. So, as we talk about the distributed data pipelines, right? I mean, the main thing was how do we put up our pipelines to for mission critical workloads, right? So, modern businesses, as we know, that cannot afford a delays or a failures in the data pipeline, right? Because it's all depend timely. We have to generate the reports out, or they make the data available for the business teams to consume it and make right decisions for the business. So they cannot afford any delays in the failures of the data pipelines. So by leveraging some of the newest technologies such as Azure Data Factory, Synapse pipeline, alongside with the distributed orchestration, enterprises can reduce the production failures by 35%. That have been proven out based on our experiences across various industries. This is improved reliability, which ensures the mission critical workloads like supply chain monitoring, digital commerce, the customer engagement, which are run smoothly, making real-time analytics a dependable capability. So, as we all know, right? I mean, right now every organization is talking about AI, right? So, you know, uh, every organization is striving towards automation, leveraging the AI to give more business value to their customers. At the same time, automate a lot of processes, legacy processes, leveraging the AI, which could help them save the cost, also give them a reliable outputs as well. So as we think about that, I know AI hungers for scalable and high quality real time data. All right, which distributed architectures would rightly fit in to help out to meet those goals. With the distributed model training, organizations can leverage the massive data sets across the clusters, while the feature stores can ensure the consistent ML pipelines across the teams, right? So which kind of gives the ability that serverless execution models enable dynamic workloads with up to 60% of the cost savings, giving enterprises the freedom to innovate without the infrastructure constraint. So, right, I mean, given how the organizations are moving towards leveraging AI, I think in order to success, to see the success in the AI, data is a key, right? So everybody is striving towards making the data ready for AI to consume it. So in order to get there, it's very important to have a reliable data at the right time at the right place, including right access controls around the data as well. So with the distributed data engineering, we could achieve all of those with without incurring a lot of infrastructure costs. So this is an example, right, where the centralized monolithic data systems cannot keep up with the volume, the velocity, and the variety needed for the AML use cases. So this is forcing organizations to shift towards a distributed data engineering, which unlocks a scalability, the flexibility, and the governance at a scale which is required to meet the needs of the AI/ML use cases across the industries. So one of the critical aspect of it, right, as we talk about the distributed data engineering in this world, the governance and security, right, which is the key. So in any enterprise, the enterprise data, the trust is a non-negotiable, right? So in the era of Microsoft Fabrics, the distributed design embed with the governance at every layer, from fine-grained access control policies to built-in compliance controls. So it's all like leveraging the metadata-driven discoverability to ensure transparency, while domain-based ownership prevents centralized bottlenecks. So the outcome is the secure, trusted environment where data flows freely, meeting both regulatory as well as the business requirement. So essentially, like with the era of Microsoft Fabric or the Lakehouse architectures, which everybody is embarking towards today, where it gives the flexibility that the data can be at the domain specific area, whereas the governance, security, the policy management is at the center, right? So they're leveraging a lot of the catalogs, the enterprise catalog, right, which can enable that forces the policies at the center, while the data can be secured at the domain specific ownership. So, I mean, if you talk about the Microsoft Fabric, right? I mean, it has the OneLake as a single the governance store where Enter for their identity and RBAC accesses, the purview for a compliance on the lineage standpoint, which consistently ensures that the data across all the Fabric workloads. So I think this is one of the example how the Fabric would help and enforce the governance and the security at the center while maintaining the flexibility. So this is just like give a quick glimpse of how the governance model of the Microsoft Fabric would work, right? So the Microsoft Fabric's the core is the OneLake as a single trusted data lake, while the Fabric workloads, which includes the data engineering, science, real-time analytics, Power BI, and all of those, would consume the data from the OneLake, leveraging a centralized governance model, which is maintained at the view, right? And at the same time, are the core foundation for the distributed data architectures or the Lakehouse architecture is going by the open source file formats, which is the 4K or the Delta table format or the Apache's open table formats. So these are the key table formats which everybody is going towards leveraging these technologies to build a domain-driven the distributed data architectures across industries. So as well see like distributed data patterns in Fabric, right? So I think mostly which kind of Microsoft Fabric which enables a distributed data pattern that empowers more sorry that empowers modern enterprises with data mesh and the domain oriented design, where domains manages the data as a product for resilience and ownership, whereas polyglot persistence, which supports multiple storage formats and engines, right? So which includes our Parquet format, Delta, or the Apache's open table format, and all of those things. The federated queries across the sources, which seamlessly access the diverse data sets without decentralizing them. So the federated query access across the sources, right? I mean, basically, the data can be at the domain level, which is close to their domains or departments, where the queries could go seamlessly across those, leveraging the centralized catalog. And the other is like which is optimized for AML use cases, right? Mainly for advanced analytics and AML use cases, which solves the need for the data requirements for our model training, and also feature stores and whatnot. So these patterns make the data scalable, accessible, and also the AI ready across the enterprise. So which is critical in the current world, where AI requires the data in order to meet or kind of prove out the success of the AI use cases. Excuse me. So as we talk about the distributed foundations of the distributed data engineering, right, what are the best practices which we could look at as we implement these architectures, right? So to maximize the power of the distributed data architectures, for example, if or see the lakehouse architectures, or Microsoft Fabric, how do we maximize the power of these technologies? Mainly to adopt the open source standards, right, which includes the Delta, the Apache, Iceberg, or the Hoodie, kind of open table formats, which would allow the agility and the flexibility, and use the enterprise catalogs to make the data easily discoverable, right? So when we adapt to these open table format or open technologies, the data could sit anywhere, which is in any storage which is closer to the domain, and we could kind of leverage the enterprise catalogs at the center, which would help the consuming engines to discover the data where the data is there, and also kind of enforce the policy and the security at the center while consuming it, right? So implement the data quality and the lineage tracking for the trust and reliability. This is must, right? Because data quality and the lineage is pretty important, as how the data is coming into the ecosystem, how it kind of interact with other domains within the data is important as well. We're leveraging the distributed compute to eliminate the bottlenecks. So we always kind of leverage the distributed computing technologies to process the data, which alleviates some of the bottlenecks with our centralized platforms in the past. Make governance and the compliance as core part of the design, not as an afterthought, right? Because as we have been seeing, a lot of the data analytics or the data management projects were failed because everybody was thought that, okay, first put the data, dump the data into our lake host, the data lake platform, and think about the governance and security later, which kind of become very cumbersome and unable to manage, like various organizations had to roll back their strategies. So one of the main reasons for that is not thinking about the governance, the compliance, and how do we treat our data, and how do we manage our data assets as we put into the any of the new technologies, right? So I think it's a very fundamental and important thing to think the governance and the compliance, which is core part of our design, right? And that will ensure that we maintain the data securely, and share with the right people at the right time with the right access privileges to those who needs the data. So these are some of the guiding principles as we embark on a journey to implement distributed data architectures. So as we look further, right? So the future of the enterprise data is pretty adaptive, federative, and also product oriented. So the data can be discoverable and reusable and owned by the domains. So which is breaking down the silos, right, and enabling the faster insights. So which would help AI seamlessly embed within our architectures as we build towards it. So which kind of making intelligence a natural part of everyday work of every function rather than afterthought. So kind of self-service analytics empowers the business teams to innovate independently, accelerate digital transformation at scale. So as we build these technologies, kind of help organizations to move towards achieving the AI functioning well, and also enable the self-service analytics to empower business units as well, so that they could independently do analyze the data, come up with the analysis, and also help them feed the business needs of their organizations. So I mean, this is one of the example, right? I mean, how example which kind of illustrate how the distributed data in the real world, real life scenario. So one of the use case was like analyzing the customer data across multiple sources, right? So which kind of, when we built this into leveraging the distributed engineering technologies, we can have multiple people, right? Data engineer can ingest and prepare the data, right, using the tools such as the data factory, data flow, lake house, whatnot, right, and which can connect across multiple sources. Whereas the data scientists can build and train the models leveraging the same data set where it stays, instead of the copying into the different platform. Similarly, business analysts can visualize the data to share insights, right? Leveraging some of the our tools such as Power BI, integrate that with the Fabric and all of that sorts as well. So here, what we're trying to say is we can have the data comes from the data from the multiple sources, right? Where we could process, which is closer to the source. However, integrate all of them together, leveraging a lakehouse platform with a centralized governance at the top. This is just a kind of a example where we can see here, right, the data engineer could leverage the data flow gen to process the data from the SQL from the Salesforce systems, whereas and integrate that with the lakehouse. Similarly, data scientists could leverage the same data which exists in the lakehouse using the notebooks to analyze the data, right? And the business analysts can leverage the Power BI connect to the same lakehouse platform to draw the insights out of it. So which kind of telling that data sits wherever it is, and avoid the copying of the data, and everybody can use the data to meet their needs, right? So that's what we intended to say in the distributed data platforms. So what are our key takeaways with this, right? So distributed data engineering is no longer an optional, right? It's a foundational for modern enterprises to meet the current needs of the data exploration, to meet the needs of the AI, ML use cases, and whatnot. So the Microsoft Fabric provides the tools and architecture patterns to achieve the scalability, cost savings, and the governance, right? Similarly, the convergence of AI and the data-driven engineering is driving the next generation of the intelligence systems, right? Which kind of enabling the enterprises to engineer the intelligence at scale and stay ahead of the competitive landscape. So it's kind of giving the opportunity or kind of leverage for the organizations who are embarked on this journey, giving an advantage of going and meeting these needs of the AI in the near future. So yeah, I think that's kind of pretty much in this session we just covered the journey of the data from the exploration challenges to how the distributed data architectures and also the Microsoft Fabric ecosystem could help adopt the trends and the road ahead, and also overcome the challenges within the centralized architectures. So let me skip this one. Yeah. All right. I just want to throw a quick poll out there, right? So not sure if how many can see my screen, but if you could answer this in a chart, that would be great. So which tool is commonly used for distributed data processing in big data environments?
Guys, if you know the answer, you can just write in the chat for sure. So, which tool is commonly used for distributed data processing in big data environments? And for those guys, who are watching the recorded session afterward, you can just comment it on the uh on the under the video. Cool.
Right. right?
Anyone can reveal the answer?
Yeah, the answer is the Apache Spark, right?
Apache Spark. Okay.
Yeah, I have a second other question as well, right? So, we have
Oh,
been seeing this, right?
we
So,
had a
sorry.
Tony. Is it the B's answer is for the previous one or for the current one?
Okay, the
Yeah.
B
So
Apache Spark is for the
Tony.
previous
Yeah.
one.
Tony just answered that. Yeah.
Okay, yeah. The
Mm,
second one, right? So, what is the primary benefit of using the Lakehouse architecture, right? I know in the emerging world, most of the organizations are talking about the Lakehouse architecture, right? Which combines the traditional data warehousing and the Lakehouse together and kind of bring the benefits of both into Lakehouse architecture. So, what is the main benefit
mhm.
of this architecture? I know it can have more than one answer from my options here. Feel free to
Yeah.
answer that.
Tony says B combines the data lakes and warehouses for unified analytics.
Yeah, and C as well, right? So I think with the Lakehouse architecture, which
Reduce data
also
movement.
reduces the data movement as well. So
Yep. And someone on LinkedIn was, yeah, this Ishan. Wonderful session. Thanks. And
thank
he
you.
answered B. Awesome. Thank you very much. Thank you
All
very
right.
much, Praveen. That was a great session.
Yeah. Thank you,
So,
everyone.
yeah, I've got a question for you.
Sure.
So you might have covered that, but if I missed that, sorry. Uh, for distributed architecture in Fabric,
Yeah.
we basically how it is going to be achieved in Fabric, let's say, first of all.
Yeah. So I think Fabric is basically okay. So let me put it this way: the distributed data engineering, right, would be kind of required to leverage the data fabric's capabilities, mainly the Microsoft Fabric capabilities, right? So what I meant to say is that the Fabric has the lake house, right, which kind of centrally manages the data centrally, right? Uh, but with the leveraging the distributed data technologies, we could keep the storage on the data which is at the domain level, right? Leveraging some of the open table formats such as Delta or Apache Iceberg or whatever it is. Uh, However, we could map those, leveraging those into our fabrics using a catalog, right? So that way we could have the data processed at the domain specific departments and integrate that with our Lakehouse platform, leveraging a Lake enterprise catalog, right? That way we're just trying to say is that in order to achieve the lakehouse architecture, we would have to go towards the distributed data engineering. That's what I'm just trying to say.
Yeah, and maybe the thing that comes to my mind is that uh, we have a separated, let's say, domain or
Hmm.
workspace,
Yep.
basically. A
Hmm.
separated workspace and having the data lake, for example, a workspace for sales, a workspace for marketing, a
Marketing.
workspace for finance, right?
Yep.
And operation, whatever. Then these are in different workspaces. Developers then can just do the things, and then the data can be centralized, or they can make use of them. Anyway, the data is still living in the OneLake, in the
Yep.
centralized data storage, but they are logically sitting in the workspaces.
That is correct. That is correct. Yes.
Awesome, cool. Thank you very much.
Thank you.
Gonna share my screen again. This session with Praveen is almost done. Thank you very much for your time again. For those guys who missed that, or you would like to watch the recording, it is going to be available on our YouTube channel immediately. And our next session for next week will be with Matt Gordon. He's going to just walk us through the engineering intelligence at scale. Sorry. The title of this is uh,
Fine.
Praveen's session, but let me just read it, correctly. It is revolutionizing data in motion, right? For real-time intelligence in Microsoft Fabric. My bad. It is the title is going to be changed for sure. It is not the title, but it will be next week at 6 p.m. Pacific time on Friday. Uh, yeah, and if you miss the session again, or you're not part of our network in the different channels and different platforms, feel free to follow us there, and don't forget to uh, rate the session for us on Meetup, and also stay tuned for the announcement for our upcoming session for next week with Matt Gordon. And yeah, with that said, we can wrap up the session. Praveen, if you have anything to add, feel free to add it. If not, we
No,
can just enjoy our weekend, and wishing everyone, have a good weekend.
thank you everyone for watching. And yeah, feel free to
Again,
comment out on the chat if you guys have any questions. And yeah, thank you all.
again, thank you for being available. It is almost midnight for you.
Yeah,
We really appreciate it. Have a
no
good
worries.
one.
Thank you. Cheers.
Cheers. Bye
Thank
bye.
you. Bye.